I remember it to this day. I made the decision to study physics after listening to a class on Copernicus. His experience, as well as many other examples in history, demonstrate the power of science to change not only what we know, but how we think about ourselves and life itself. NASA is doing civilization-level science, whether that's with our research and science programs or our human exploration program. And that science has not only changed how we think, but also has provided a surprising number of practical applications that are affecting all of our lives every day. Civilization-level science is truly a characteristic of explorers. And that's also a deeply human characteristic, just how I want to remind you of your own memory now. I am sure you remember the first time you felt it, that sense of universal wonder. As a child, you looked up and you saw the night sky in all its silent glory. It covered everything around you, and it was ever present. It was straight out beautiful, and you knew deep in your heart that it was important too. You can look at the sky again the next night, and went on travel to the beach or the mountains, and it is still there, and it is still beautiful, and it is still important. And it changes. New things become visible. The heavens are shifting, even as they seem constant to us. They reward repeated investigation. As we grow up and keep looking at the sky, to many of us, there are two overarching thoughts that are emerge, and both of them related to exploration. First and foremost, there is a sense of unity with all humankind. Because even though people around the world will look at different parts of the sky at different times, it is the same sky for all of us and the same importance. The stars and the sun shine on all of us, and we live under the same firmament, like one huge tent. And in that tent, we have united in our most fundamental experience of science, and united in our human condition. And the second thought that emerges is about questions, about the why, the what, and even the who related to these observations. Science and philosophy are tied together as we gaze skyward. And if you share that experience with a child, there is an inevitable consequence of this very human experience, those very important questions. These questions reflect an innate curiosity we all have in us about our experience of the universe. They may not always have answers, but they point towards possibilities. We who never stop looking at the stars, we wonder, both the scientists and those filled with fascination of the great unknowns all around us, wish everyone could see what we see. If we start answering the child's question, we think about them for ourselves. The sense of awe and the vastness of the sky and the amazing phenomena going on all at the time throughout our cosmos. That sense of the importance of our observation and how they unify all of us, all become bigger, always more important. It has always been so since humanity first started to pierce the veil of the sky above us and piece together what we could. Socrates himself said, "Man must rise above the earth, to the top of the atmosphere and beyond, for only thus will he fully understand the world in which he lives." The insights we get from science and telescopes and robotic explorers enrich our view of the world in ways that we could not have predicted. And by world, I mean that in the broadest sense of our home planet and the cosmic sea in which we float. We learn, for example, that the sky is not at all calm, as the vast cloak of silent darkness at night might seem to indicate. This appearance is merely because of the timescale of change out there. Time periods incomprehensibly long when compared to our human life. Stars are constantly being born. They go through an evolutionary history enormously larger than the human lifespan and often find violent and explosive ends. Ancient rocks collide with one another and even with the Earth. The surface of many planets and bodies rage with storms larger than continents or push water into space with explosive force or nurture the building blocks of life that might once have existed in similar form here. And this violence and chaos, which nonetheless follows rules if we can just understand them, this, it seems, throughout the universe. Many philosophers have thought about this key insight, but I'm going to use the words of a child here to talk about that very feeling which is applied to our science and exploration programs, and especially the exploration of Mars. Curiosity, insight, spirit, opportunity. If you think about it, all of these names and past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. Those, as I said, are the words of an inspirational young man who came up with the name Perseverance for our rover that launched to the Red Planet this summer. It was inspiring to hear this young person, who is truly of a new generation of explorers growing up now, the Artemis generation as we call that, reflecting that the motivation for much of science is reflected in qualities we have as humans. These are qualities that our children often understand better than we do as grown-ups, and qualities that motivate us to go forward. It is the childlike why question that is at the heart of all of what we do. It's a beautiful and motivating message, and it pulls us forward and not only changes what we know, but how we think about ourselves and our place on Earth and in the universe. It is the why paired with the actions and determination to find answers, but it is also continually renewed as the why keeps growing. We have spent over 20 years in low Earth orbit on the International Space Station, a global partnership that is unprecedented. If you're younger than 20 years, like both of my children, there has never been any time in their lifetimes when humans beings were not off the planet. Americans were not living and working in space, as well as their international partners. We have learned much about routinely leaving Earth and living in space, and though it remains an extraordinary feat each and every time, we have seen the many stunning images looking back at Earth, with the beauty of the aurora and the night sky, the sheer power of natural forces and storms, but they all show how Earth is united and unified. Whether that's an aurora dancing across the arc of the magnetosphere, or disturbances forming in one part of the ocean and impacting land half a world apart, it is all one planet with borders of geography and oceans, but nonetheless one big place where humanity's borders pale when seen from above. Our fleet of Earth observation satellites has grown tremendously in the last 3 decades, enabling us to have eyes in the sky looking at every aspect of our planet. It is essential that we do this because our planet is made up of an interconnected system of systems, and so we have satellites to look at precipitation, the atmosphere, the oceans, the ice, the land, and many other subsets of these systems. We learn about the slow changes of our Earth, caused both by natural processes and also by humans. We are learning about the connectedness between us here on Earth. We all breathe the same air. We are surrounded by oceans that are rising in the atmosphere that is warming globally. Every day, these critical satellites also warn us of disasters and help us recover. Their data help give farmers more information to help them with critical job of being more effective in their work. And they help us all see how our planet is changing. Because of rovers' life curiosity, spirit, and opportunity, we have received insights into our universe and ourselves. We followed the water and learned that Mars might indeed have once been habitable. Exploration and research have continued to unite us, from those first real pictures of the surface of Mars taken by Viking, to the bated breath of everyone on the planet as Apollo 13 struggled, to the celebrations as Hubble's glasses gave it the piercing vision back in time and across the cosmos that it has had ever since. We have one sky, one sun, one Earth, and we explore it together to the benefit of all of us. We have the gift of questions, and those questions are a legacy on which we continue to build. Those qualities continue to be renewed in each generation as they make their own giant leaps and pursue the questions most meaningful to them. But as we plan for the bright future of science and exploration, there is one additional element, one equal human behavior that has been just as important as curiosity. In fact, the only way we got these amazing pictures of the universe from our telescopes, from our orbiters and landers at other worlds, and the only way we got people into space in the first place is through perseverance. Curiosity and perseverance are two sides of exploration that have always been with us and are always linked. This year we celebrated the anniversaries of both the Hubble Space Telescope and Apollo 13. I believe that the Hubble Space Telescope is the most magnificent telescope ever built by humans. Conceived by leaders like Lyman Spitzer and Nancy Grace Roman, this telescope was built with very tough challenges, both technically and programmatically. And when it was finally launched, Hubble was short-sighted and a huge disappointment. Its mirrors were not correct. But through perseverance, Hubble not only became the most successful astrophysics mission to date, but also the best demonstration of the confluence and mutual importance of science and human exploration. Bold astronauts flew to the telescope multiple times over the years to make Hubble better than ever and extend its life. And now, with over 150 terabytes of data on the ground, and the international community of more than 12,000 active researchers worldwide have written over 15,000 publications on its amazing astronomy. And the number is increasing now by about 1,000 publications each year. There has never been a space mission with this magnitude of scientific impact. Remember that this was enabled by the perseverance of those before us. And telescopes like Webb and Roman will build on the ingenuity and require perseverance to overcome the challenges that will surely come. We can look at the Apollo 13 mission in the same way. There was certainly the same optimism of a country on a roll. And I'm sure that the entire team wished that Apollo 13 would have been as smooth as Apollo 11 and 12. But immediately after the accident, that dramatically altered mission and the famous quote, "Houston, we've had a problem." The Apollo spirit and sheer excellence of the integrated team on the ground and in space came together and brought the astronauts back safely. Their trip of nearly 6 days was filled with innovation, ambiguity, and fear, as Jim Lovell and his crew members depended on Gene Kranz and his ground crew. What initially looked like one of the most deadly disasters in the history of space travel turned into a story of leadership, of teamwork, of unquestioned strength and success, and we persevered. It was perseverance, not giving up under pressure, and when challenged, that got Apollo 13 astronauts back home safely. And that helped us be safer and accomplish the mission the next time. Perseverance has always been part of exploration, and it will forever be. Using our Artemis program, we are moving astronauts out of low Earth orbit and forward to the moon. We want to go back and land with the first woman and the next man, as we want to have a sustained presence on the moon and we seek to reach our next goal, the goal we have never reached before, bringing humans to Mars, where they can explore the same terrain as all those missions with the intriguing and inspiring names, and will be able to bring scientists first to the lunar surface and later to Mars as well. And just like other milestones achieved by those who came before us, we too must recognize that reaching big goals is not just about spirit and opportunity and about values that pull us forward. It is also about perseverance. Do not give up when things are tough. Make no mistake, getting to Mars will be tough. It always is. Our next rover is aptly named because it will take perseverance to survive, to go the distance in the rugged environment of Mars. And all of our human explorers face incredible challenges as well. I believe we were meant to explore, but doing so makes us first face some incredible obstacles, which we can face with science and with perseverance. Let me talk about two elements that are critical in this realm: managing the dangers of space weather and sending science to lead the way for humans. The Biological and Physical Sciences divisions has joined NASA's Science Mission Directorate, coming from the human exploration side of NASA. We look forward to working with them and their intriguing projects to use aspects of the spaceflight environment and study biological and physical systems, and study how these systems respond to gravity and radiation, among other factors, which can lead to scientific discoveries that might one day help enable prolonged space exploration and also benefit life on Earth. Our Sun is an active and variable star, and besides its radiation, adds hazards to our journey in space. This variability can be manifested by major emissions of high-energy flares and ejections of solar material. We have been studying those magnificent events using space assets and are making progress in understanding their physical processes that shape them. What is not visible in these pictures is one important side effect of these violent eruptions: the acceleration of very small number of particles up to nearly the speed of light. The vast majority of them do not make it to Earth because of both the Earth's magnetic field and the very thick atmosphere between us and the sky. Humans who will travel from Earth on the way to the Moon and to Mars away from that earthly protection. Just like weather forecasts on the seafarer, space weather forecasts and situational awareness are important ingredients for all of them, and to persevere through the challenges of space travel and the fury of space weather. This is why explorers that venture to the Moon and beyond will have to be prepared for both those often unpredictable eruptions coming from the Sun and the other high-energy particles that come from the outside of the solar system, galactic cosmic rays. Unlike the predictable solar ejections, there are far fewer galactic cosmic rays, and they enter the solar system at a fairly constant rate with a maximum flux during solar minimum conditions, which is just about now. Understanding the radiation effects of both solar and galactic radiation on the crew and the plants and microbes they bring with them in exploration is a major focus of our research program. For example, the damaging effects of radiation on DNA on the resulting higher risk of cancer has been known for decades, but research has shown that space radiation causes more of the DNA damage that is difficult or impossible for cells to repair. Moreover, cells that have been hit by space radiation can damage nearby cells, including their DNA, through processes that are not yet understood. Besides the biologic impact of these particles, we are also interested in how those effects are modulated by microgravity and other aspects of spaceflight. Thankfully, we are entering a new phase of research focused on this environment of space. NASA's Parker Solar Probe is breaking new records, going ever closer to the Sun than we've ever been before, while measuring the plasmas, fields, and those particles in this never-explored environment where they originate. We are learning that this is a violent pit there, with a structure that has escaped many of our models, which were built before, and we're able to study the environment so closely. We are excited because we will also learn more about the Sun from ESA's recently launched solar orbiter, which will bring cameras into the inner system of the Sun, and also to higher latitudes of the Sun, promising to shed new light on the connections of the solar activity local to the Sun and the radiation beyond. We are so committed to this that we are putting a weather station and, with our ESA colleagues, a radiation-focused suite onto the gateway that will orbit the Moon and eventually serve as a base for astronauts. These measurements near the Moon are interesting by themselves, and our scientists want to learn more about the lunar environment. But they're also part of a system of tools we will need to travel ever deeper into the solar system to keep astronauts safe from the onslaught of radiation from the Sun and beyond. In all cases, whether to the Moon or to Mars, science leads the way. We are able to take more risks with robotic explorers than with humans, and we can learn about environments and resources to be encountered once humans arrive. We still uncover things years after data are collected, and we are trained to analyze and correlate and synthesize. This training is essential for us to realize our aspirational goals to go to Mars with humans, which will be one of the most difficult objectives ever attempted in the history of spaceflight. Mars, as we have learned, is both a stunning and a challenging target. In fact, nearly 50% of all Mars missions have ended in failure, and landing on its surface is one of the most difficult goals ever attempted. Just with Apollo 13 and many moments in our history, we will keep the cameras on, even though we know of the risks. We seek to achieve this goal again as the Perseverance rover now speeds towards Mars for a February 2021 landing. The instruments that are part of this mission are laid out to give us the information to collect the most valuable set of samples ever. Samples of Mars that we will later bring back to Earth. Samples that are addressing a very simple question: has there ever been life on Mars? That has never been possible before, and we're making it possible. This Mars mission is a true astrobiology mission, focused on the origins of life away from Earth. It was very hard to get this mission ready, even before the challenges of COVID, but the team persevered in perfect alignment with their namesake mission. And it is perseverance that will ultimately achieve the big goals that yet again change the history books. And to answer that childlike why, the rover is also equipped with more cameras than ever, a microphone, a first, and many other sensors that will enable all of us to experience the Martian environment as never before. All missions face their own obstacles, but we keep them going to the best of our ability to chart the new story of humanity on another planet and in space in ways we cannot even comprehend yet. That is the story of exploration and the seed of perseverance on which we all rely. A seed that grows from necessary question: how does that work? How can we learn more? And maybe, can we visit a faraway place? We are hopeful because the next generation will come and complete this journey, and that is inspiring to all of us. I've been using the words from one of these students to frame this presentation. I'm going to let Alex Mather, the 13-year-old student who named the Perseverance rover, end this talk with his wise words about how humanity will persevere into the future.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans. We are always curious and seek opportunity. We have the spirit and insight to explore the Moon, Mars, and beyond. But if rovers are to be the qualities of us as a race, we miss the most important thing: perseverance. We as humans evolved as creatures who could learn to adapt to any situation, no matter how harsh. We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere. We, not as a nation, but as humans, will not give up. The human race will always persevere into the future.